Hello guys, in this video I'm going to explain to you the weekly Leetcode problem minimum operations to form the subsequence with the target sum. So in this problem, let me refresh and check how many people solved this. Okay, 1,000 people have solved this problem. So in this problem, what we are basically given is that we have been given a nums array. In this array there are non-negative powers of 2 and they have also given us a target. So what we have to do is that we have to pick some subsequence of this nums array, and we have to uh, get the sum such that we have to pick a subsequence of this nums array such that the sum of the subsequence will be equal to this target. So basically we have to pick some elements from this nums array such that the sum will be equal to the target. So and like we can perform we can perform an operation on this nums array. The operation is that we can choose any element from this nums array such that the nums of I greater than 1, and we can then remove that element. Then we can add two occurrences of the half of the element that we took to the end of the nums array. Actually, adding to the end of the nums array is not relevant. Like this is just here to confuse you. Like if you add it to anywhere in the array, it's a valid solution, and like this is just here to confuse you. You just need to note this sentence: add two occurrences of nums of I by 2. That's it. And we have to find the minimum number of operations that we need to perform such that we can form a subsequence such that the sum of the elements will be equal to target. If it is impossible to form such a sequence, we just have to return -1. So initially I tried a few approaches, and I was able to arrive at a answer. Then I tried different approach, and I was able to get a accepted solution, and I will explain to you that approach. So in this approach, what I'm gonna do is I'm gonna first write the target in the binary representation. So if you write it by binary representations, the target will be sum of 4 and 8, right? 4 8. Likewise, if you consider target 7, the binary representation of that would be 1, 2, and 4. So we will first write the target in the binary powers of 2. No, not binary representation, powers of 2. So this is the target. So I will store this powers of 2 of the target in a array or something. So I will first store the array, then I will take the nums array. So this is the nums array. Then I will take the nums array and I will sort it. 1, 32, 1, 2. So since we just need to take a subsequence and not a subarray or anything like that, so sorting doesn't affect the solution actually. So sorting doesn't affect the solution. So now what I'm gonna do is that, okay, sorry, sorted. I have to sort it. 1, 1, 2. Now so now I'm going through the target array. So inside the target array, we first consider the first element. We will check whether the first element is equal to the first element in the nums array. Since it is not equal, uh, we have to perform something like and we have to check for two conditions. We have to check whether if it is not equal, we have to, if it is equal, we can directly remove. If it was a 4 over here, we can directly remove both the 4s from both the arrays. But since it is not equal, so if it is not equal, there are two conditions. It can be lesser than 4 or it can be greater than 4. So I will first explain to you the condition where it is greater than 4. 32 is greater than 4. If it is greater than 4, what we have to do is that the only thing we can do is that we have to perform this operation. We have to perform the splitting operation some number of times such that we will get a 4. And like we are guaranteed to get a, like since this is a power of 2 and this is a power of 2, by splitting this power of 2 we are ultimately we will get 4, like we will get whatever number is over here since both are powers of 2. So if the element inside the nums array is greater than the the array, the number in the element in the target, we have to split it greater than. So if the element in the nums array is greater than the element in the target, the only possible uh, operation is splitting it. But like in this example that they have given us, the element in the nums array is lesser than the element in the target. So what we can do is that uh, like first we can pop this element from the nums array, and then we will check whether the popped element is equal to the next element. If the popped element is equal to the next element, we will pop the next element as well, and then we will uh, enter the sum of the both elements into the uh, nums array. And then we will, so now we will check whether 4 is equal to 2. No, 4 is not equal to 2. Then we will again pop the first element of the nums array, and then we will check whether the pop element is equal to the next element. It is equal to the next element. So we will pop the next element as well, and then we will input the sum into the array. Okay, now we can see that 4 is equal to 4. Now we can remove both the 4's from both the arrays. And now we can see that we have 8 and 32 remaining. Since we have 8 and 32 remaining, we can split this. We can split first this 32 first into 2/16s. We split the 32 into 2/16s. Then we can split this 16 again into 2/8s. So we have performed a total number of 2 moves right now, splitting moves. And now we can see that 8 is equal to the first element of this nums array, so we can directly pop both of them. Now I will show you the condition where like earlier we added the element and added the element if the next element was the same as the popped element, we added the sum back into the array, right? So I'll explain to you a condition where the popped element is not equal to the sum. So suppose this is the array that they have provided with us. So like first we will add these two, and we will input into the nums array, and we now 4 is not equal to 2. So since 4 is not equal to 2, I will check with the next element of 2 whether it is equal to 2. No, it is not equal to 2. It's equal to 4. So since it is not equal to 2, we will just remove this 2. We will not consider that again. Because like we are doing that because like we know that the elements in this target array are powers of 2. And like if we add some elements and if we add the elements in this nums array which are not equal, we will never obtain a power of 2 that we want. So like if we add this 2 and 6 2 and 4, we will get a 6, which is not a power of 2, which defeats our purpose. So the optimal thing to do is remove that 2. Now we will see that 4 is equal to 4, and we will pop both of them. Yeah, that's my solution. Like I will explain to a test case where it doesn't work. Like this test, I will explain to you this test case. So we'll first solve the nums array 132. Then I will form the target array. Target array is the powers of the target that they have provided us. Like so, if we divide it into powers of 2, it will be 1. Then 1 and 1, 2, 32. Yeah, this will be the powers of 2 of the target. Okay, now I'm gonna perform my like. Okay, now first we will check whether 1 is equal to 1. Yeah, 1 is equal to 1. We will pop both of them. We will remove both of them. Now we will check whether 2 is equal to 1. No, 2 is not equal to 1, and 1 is lesser than 2. So we will check whether the next element of 1 is equal to 1. No, the next element of 1 is not equal to 1. So we will just remove this one from this array. And now 32 is greater than 2. 32 is greater than 2. So we will split this into 16, 16 first. Then we will split this into 8, 8. Then we will split this into 4, 4. Then we will split this into 2, 2. Now we will see that 2 is equal to 2. We will remove both of them. And now we will go for the 32. 32 in this inside this array. Okay, 32 is not equal to 2 and 2 is lesser than 32. So we will check whether the next element is equal to 2. No, it is not equal. So I will remove 2 from the array. Now 32, 4 lesser than 32. So we will remove, we will check whether the next element is equal. No, it is not equal. So we will remove the 4 from the array. Now 8 is lesser than 32. We will check whether the next element is equal to 8. No, it is not equal. So we will remove 8 from the array. Now 16 is less than 32, and there are no next elements, so we will remove 16 from the array. And like since like we are not able to entirely form the target that we wanted, so the output will be a negative one. Now I will show you the code for the problem. So I used a priority queue to store the nums array, and I used a vector vec to store the powers of 2 of the target. So initially I pushed all the elements inside the nums array into the priority queue. This priority queue is sorted in the increasing order. Usually priority queues are sorted in decreasing order, but like if we add this extra terms into our priority queue container, we can sort it in increasing order. Then I pushed the elements into the priority queue. Then inside the vector vec, I pushed the powers of 2 inside the vector vec. Okay, then I declare two variables, integer j and integer moves. This will contain the number of moves that we perform. This will contain the index that we are pointing to in the vector vec. So currently we are pointing to the first index of the vector vec. Now we will run a while loop. We will run the while loop while particle not equal to empty, or whether we have exhausted through all the powers of 2 inside the vector vec. So if j greater than vec dot size, we will know that we have combined we got all the corresponding elements in the target array. So target array is equal to 0 right now. Now we will first pop the first element of the priority queue. We will first take the first element of the priority queue, then we will pop that element, and then we will check whether the first element is equal to the vec of j. If it is equal, we will increment j. Else, if vec of j greater than the first element, so the first element is greater than vec of j, so we will push the half of first 2 times, and we will increment the moves variable by 1. Now we will check whether first we have to now we have to check for the second condition, right? If so if the element in the nums of array is lesser than the element in the target array, so for that we have to check whether the next element is equal to the element that we are currently considering. For that, there, there needs to be at least 2 elements in the array. So for that I am checking this condition, if 2 equal dot size greater than 0, because already we popped the element, the first element, and now we will check whether there is some space for popping the second element as well. If there is space for popping the second element, we will store the second element in the pq.top, the second variable, and we will check whether if first is equal to second. If first is equal to second, we will define a variable total, which is the sum of first and second. Then we will pop second from the second element from the priority queue. Then we will push the total into the priority queue. Now at the after the while loop, we will check whether the our pointer has reached the end of the vector vec. If it has reached the if it hasn't reached the end of the vector vec, we haven't gone through all the powers of 2 in the target vector. So we will return -1, otherwise we will return the number of moves that we perform. And this code is a accepted code. It's accepted. Like I will check for some of the details. Okay, runtime is less. Memory usage is also very less. Okay, I will check. Like I will try to run from the main page so I can get a clear idea of the memory usage and all. Yeah, like runtime is it can be better. It can be runtime can be better. It only beats this percentage of users, but the memory is very critical. So this is my video solution. Like I will try to improve my explanation skills and like okay, yeah, that's it. Thank you guys.